Ensoftec's HydrologyVA is an engineering tool which provides computations for the different hydrologic methods used in the Commonwealth of Virginia. In this video, I shall show you the Anderson method design module. The Anderson method was developed by the USGS to evaluate the effects of urban development on floods in northern Virginia. One of the advantages of this method is that the lag time, T, can be easily calculated for drainage basins that fit the description for one of the three scenarios given: 1. Natural rural basin, 2. Developed basin partly channeled, or 3. Completely developed and sewered basin. I click on Anderson method. This opens the Anderson method design folder. At the top, you will see a pull-down list of the counties and the principal cities in northern Virginia. This is for information only. I can select the units, English, for the United States customary units, or metric for standard international units. Below the county or city field is the number of sub-areas field, where I can select the number of sub-areas for each type of land use within the drainage area. I can select up to 10 sub-areas. Let me select 4. This opens a table of sub-area description, corresponding area, A in acres or hectares, and the corresponding impervious area, in acres or hectares. The number of rows in this table correspond to the number of sub-areas selected. These are open fields and permit my filling the table with the appropriate data for all the 4 sub-areas. I next click the Accept button. This calculates the total area, the impervious area both in acres and in square miles for English units, and in hectares and square kilometers for metric units, the net percentage of basin covered by impervious area, and the corresponding coefficient K. I can always click on the Clear button to restart the above steps. Next, I select the land use type from the pull-down list of the 3 scenarios that I mentioned earlier. Time lag for each of these watershed types is a function of length along primary watercourse from site to watershed boundary, and an index of basin slope based on slope between points 10 and 85% of the length of watercourse, as shown in Table 6.3 of the manual. I enter these fields and click on Compute Time Lag. The time lag will be shown in hours. I next click on Compute Discharge. The program calculates the flood frequency ratio and the peak discharges for different recurrence intervals based on Table 6.3 and Equation 6.6 of the Drainage Manual. The results are populated in the bottom right of this form. I can preview and print the results, either as PDF file or send to printer. Exit will close the Anderson method folder. This completes the Anderson method module.